Good morning, friends. As you know, I am Dr. Dwivedi, Professor from the Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. I am starting another course, that is Engineering Thermodynamics. The course code of this is AAEC02. I am basically aeronautical engineer, worked 20 years in Indian Navy as a aircraft maintenance engineer, and from last 12 to 15 years I am as a teaching in the Department of Aeronautical Engineering. Before this, I have already completed two courses. One is aircraft stability and control, and the next one is aircraft systems. This is my third course which I am starting today, that is Engineering Thermodynamics. Hope this will be very useful. I will try to explain something new which are related to the aeronautical or aerospace domain in due course of time. I will also try to discuss some research areas related to thermodynamics, which are also common for aeronautics. Today's topic I am going to discuss about introduction and the course description. In Institute of Aeronautical Engineering, it is customary to start with course description for any course, and also what are the objectives and outcomes of this course. This I am going to discuss in this topic. In today's lecture, I am going to discuss about introduction to outcome-based education, discussion on course description, course objective and outcomes, introduction and historical background of thermodynamics, scope and application of thermodynamics. These topics I am going to cover in my today's lecture. So, outcome-based education, what is this? I will just go in brief. Hope the learners of this course will understand that any course which we learn, it should give some outcome. So what is that outcome, and what is the meaning of outcome-based education or outcomes-based education? There may be a number of outcomes. So it is called outcomes-based education. So this is called OBE. OBE is an educational theory that bases each part of an educational system around goals. So in this, what happens? In outcome-based education, it is related to the goal of any course. And a student, after learning, they are able to achieve that goal or not. Those goals are called the outcomes. By the end of the educational experience, each student should have achieved the goal. So whatever goals are set, these goals may be set by the AICT, by the college, by the respective agencies, governmental agencies. They will set some goal, and on completion of the semester, on completion of the course, or on completion of your graduation or undergraduation, whether you are able to achieve that goal or not. There is no single specified style of teaching or assessment in OBE. So, it is not a single method. Teachers can adopt different methods to achieve this outcome-based education. Instead, classes, opportunities, and the assessment should all help a student achieve the specified outcomes. We should plan the classes, workshops, seminars, or any other activities by which we are able to achieve the given or specified outcomes. Those outcomes are already specified, and this we have to achieve by different teaching techniques, Nowadays, we also started the project-based learning. In the project-based learning, there are few skills which students can develop. These skills are very useful for the future of any students. The role of the faculty adopts into instructor, trainer, facilitator, and or mentor based on the outcome targeted. So here, the teacher is not only to teach in the class, but teacher has to go beyond the class. It can be as an instructor, it can be a trainer for a machine or for some equipments. Teacher has to train so that students should be able to operate and they should get the skill. There should be also the facilitator, that they should provide the resources, they should provide the guidance how this can be achieved, and also the mentor based on the outcome targeted. So before I go for further outcome based education, the first and foremost thing is the level of cognizance and Bloom's taxonomy. This level of cognizance we can divide into the 6 groups. You can see it is like a pyramid, and in this pyramid, if you see, the last one here is a remember, and if you see this area of this thing is quite more, then it is the lowest level, remember, and the highest level is here, creating. So if you see here, you have a more number of peoples are here in the remember group. It means in the remember, they can recall facts and the basic concepts. In this recalling and the understanding the basic concept, they should be able to define, duplicate, list, memorize, repeat, state. These are the verbs which will follow the remember. Next level is understanding. In the understanding, we can see that explain ideas or the concept. So whatever you are remembered, after that in your language, in your thoughts, in your way, how you are able to explain. So that is the purpose of understanding. In understanding, we have some specified verbs. These verbs are classify, describe, discuss, explain, identify, locate, recognize, report, select, and translate. These are the few verbs which we should use while drafting the course outcomes and the objectives. Then third level is the apply. In this apply, use information in new situations. In that executes, implements, solve, use, demonstrate, interpret, operate, schedule, and sketch. These things are coming in apply. Next level goes to analyze. After this, achieving these 3 objectives, students should go to the next 4th level, and this 4th level is much better. In that, after application, the student should be able to analyze the things after application. Draw connection among the ideas. There may be some different ideas for one issue. So you should be able to do that. Which one is the best idea? So in this, some verbs are coming. These verbs are differentiate, organize, relate, compare, contrast, distinguish, examine, experiment, question, test. These are the things. These things will be working. Next is evaluate, justify a stand or the decision, appraise, argue, defend, judge, select, support, value, critique, and weight. These are the evaluation process. Then you can go for the create. In this, produce new or original work. In this, design, assemble, construct, conjecture, develop, formulate, author, investigate. These are the create is the highest level. In that, you should be able to create the product or the process. You can design some product, you can assemble the product, you can construct a building or anything or any model, develop some new ideas and new model, formulate the issue, write something new about that, investigate the problem. If you are able to do, then it means you are in the top hierarchy of the Bloom's taxonomy. That we have to understand. Next is discussion on the course description. Before we start the course, all the teachers and the faculties of particular course has to make the course description. And this course description means a course description is a brief summary of the significant learning experience for a course. Course descriptions appears in individual course outlines and in the program of studies for individual program. Course descriptions should be student-centered rather than teacher-centered or course-centered. This we have to understand very well. The first point. It is not the teacher who has to get the goal. It is the student who has to get the outcome. So this, your drafting of your description, it should be in such a way that you should always focus student, how the student will obtain the goal, how the objectives can be met. That type of description has to be made. Use brief outcome based descriptive phrases of active verbs, just I have shown before, that is design, create, plan, analyze. Then be clear, concise and easy to understand. It should be very much clear. Whatever goal you set, you make sure that it is very much clear to the faculty as well as for the student. Detail significant learning experiences and benefits. Detail significant learning experiences and benefits student can expect. Align with the outcome identified in the rest of the course outline. Align with the outcomes identified in the rest of the course outline. So this has to be aligned with the course identified. Here I have drafted some course objective. So a course objective specifies a behavior, skill or action that a student can demonstrate if they have achieved mastery of the objective. Objectives need to be written in such a way that they are measurable by some sort of assessment. Everything in the course should work together to ensure student master the course objectives. These course objectives are drafted by the teacher. In this behavior, skill and action that student demonstrate, means you make such a way that students should be able to demonstrate what they are learning, and the assessment should be measurable. You should measure and then assessment should be done. Here I have written some 4 course objective for this engineering thermodynamics. Next, these are the outcomes. These outcomes should be focused for the student, that students should be able to perform. They should show that these things are there. Course outcomes are central to any course curriculum. They articulate to students, faculty and other stakeholders what a student will achieve in each course and how their learning will be measured. So this thing we have to make sure that what they are going to obtain, whether the goal set during the previous slide, that is objective, whether they are able to fix and whether they are able to understand or not. Then we have a learning outcome is a measurable, observable and specific statement that clearly indicates what a student should know and be able to do as a result of learning. So these things you should be able to understand. Here for the thermodynamics, these 6 course outcomes are specified, and here if you see, you have the Bloom's taxonomy and these are the level. So here the second level and this apply are the third level. So up to apply level, we should be able to make sure that students, their cognizance level has to reach from, remember, to understand, from understand to apply. And if some students, they are very good, they can go for the analysis, evaluate, and so on. These are the competency level. So here we have out of 6, there are 3 understand and 3 apply. So our objective is to able to our students should be able to understand the topics, and also they should be able to apply as and when required. This is the syllabus which we have in our institute. This syllabus is divided into the 5 modules. Module 1 is basic concept and first law of thermodynamics. Module 2 is second law of thermodynamics. Module 3 is pure substances and mixture of perfect gases. Module 4 is power cycle, and module 5 is elements of heat transfer and gas compressors. So these are the 5 modules which I am going to cover in due course of time. And these are the topics of the module 1. Here only I am showing the module 1. As and when I will start the module 2, that time I will give all the topics. So in this, we have the basic concept. In this, system, control volumes, surrounding and all, these all things will be covered in the due course of time. Now, if you see here that introduction and history of the thermodynamics. So what is the meaning of the thermodynamics? The word thermodynamics came from the 2 words, Greek words. They are the thermi and plus dynamics. Thermi means heat and dynamics means power. So in this, the heat which convert to the power or the work. So that is the meaning of the thermodynamics. And after that, the word energy name given by the Thomson in 18th century. In the early time, man early effort to convert heat into the power. So that is why this name has come. So thermodynamics means, this is the old definition, that because that time by the fire, they used to use the fire to convert this fire energy or heat energy into the work. That is why the thermodynamics has come. If you see about the historical perspective, so the energy word first, it was introduced by the Thomson in 18th century. There are so many people who are involved for development of the thermodynamics. So in this, first and the second laws were developed around 1850 to 1870 by the scientists like James P. Joule, William Rankin, Rudolf Clausius, and Lord Kelvin. So these are the 4 people. Their contribution is enormous for finding out about the understanding about first and the second law of the thermodynamics, and most of the credit goes to the William Joule. He is the person, actually he was not very much educated, but he had started in a very young age, at the age of the 20, and he started understanding and experimenting about conversion of heat to the work, and his contribution is enormous. Then we have the William Rankin. He is the first person to write a textbook on thermodynamics in 1859. Another person is Josiah Willard Gibbs, 1839 to 1903, developed thermodynamics into a science of such broad scope and generality that now it covers almost all branches of science and engineering. Man and Energy by A.R. Lohut, 1965. It is a remarkable illustration of ranging power of the human intellect that a principle first detected in connection with the clumsy puffing of the early steam engines should be found to apply to the whole world and possibly to the whole cosmic universe. So he has the A.R. Ubilhod. He has explained that the thermodynamics not only for the steam engine, which was initially started by the James Watt, but these laws are also applicable for everyone, even star, moon, your man, human, animal, trees, everywhere these laws of thermodynamics are applicable. Now, my next topic is engineers and the scientists. So, what is the engineer and what is the scientist? This we have to understand, and what is the difference between these two. So, what are the engineers? The engineers to design and develop a product and the process. Any engineer, which especially in engineering college, we have to produce engineer. It means they should be able to design and develop a product or the process, or they can improve the existing product and the process. Suppose we have made something or it is already existing, can we make some improvement in that? If we are able to do, it means you are the engineer. One has to use available resources, that is energy, space and the time. So what is the meaning of this, and what is the scientist? There is a basic difference between the scientist and the engineer. Scientist has to discover the things from existing natural conditions. If you see, the Newton's laws were discovered in 16th century, that apple is falling from the tree towards the earth. But before that, what happened? Is the apples were not falling from the tree, or they were going upward? Means the concept, the existence of the same laws were present from beginning of the universe. But the person who is able to find out and give some formulation, give some laws on that is called the scientist. So the aim of the engineers is to make those laws useful for the society, for the community, and develop a product or develop a process, or whatever products are available, whether you can make something improvement or not. If you see the pen, when I was in childhood, this gel pens were not there, only nib pen I was using. But now you have the gel pen, you have the very fine tip pen. So this making of new things, new product, or these things is the work of engineer. If you see that, I will give the example of the scientist. Suppose scientist will discover anything in the nature, like your small kid of 1 year. That kid will feel the hotness and the coolness. Kid will also feel hunger. But he doesn't know that which law it is following. But the hunger is there. Heat is there. So the purpose of the objective of the scientist is to discover those type of natural phenomena, and they should formulate the laws. But engineer has to take those laws and make the product. So that is the difference. Here I want to give one more example, that engineers has to think about energy. Engineers has to think about the space and also the time. Within a given time, there are so many constraints. Energy is the main constant. Space available is the main constant, and how much time. If you are not able to produce the object in a given time, some other people will make the product and they will be in the market. So, engineer has to work in a given time, in a given space, and in a available energy. they have to make the product. I think nowadays we are very much talking about hydrogen extraction or the hydrogen cell technology, and so this can be produced by the different ways. First one is the electrolysis method. In this electrolysis method, H2 plus O, we use some electricity, or we made a anode and the cathode. Hydrogen will be separated and the oxygen will be separated. This hydrogen we can capture in a tank, we can store it, and then we can use as a fuel. Another method is steam carbon reaction. If we take a hot steam and we mix with the carbon, C plus H2O is equal to CO plus H2. So we have got this H2. This now carbon monoxide is not good. This has to, again we have to mix with CO plus H2O. We are getting the CO2 and then hydrogen. So this CO2 can be absorbed by the atmosphere. But if you use this carbon monoxide, this is dangerous and it is creating the pollution in the atmosphere. So this is the second method. Third method is methane steam reaction. If you take the CH4 methane plus water, it will produce the carbon monoxide and 3 molecules of hydrogen. Again this CO plus H2O, we will get this CO2 and H2. So this we will get 4H2 we will get by this reaction. If you take here, we will get 2H2 and here we will get only H2. Okay, so like this different methods are there. As an engineer, we should try to find out how much energy, because if the energy used to produce this thing is more than the we are getting, then there is no use. By expending of little amount of energy, that is the energy, and that is the space. How much space it is taking, whether it is in the given small space, if it is we are able to do or not. Because if you take the aircraft and you take a power plant, engine of aircraft and the power plant, in aircraft we have the limitation of weight, but in ground power plant we are not. So as per the space we have to think, and how much time it will take. If it is taking 10 years, it means no use. Some other people will make some other technology and your things will be no more useful. So these parameters we have to think before using any method. So in the above example and in general, the engineers quite often comes across the following questions. So engineers has to get some questions, and these questions has to be answered by the engineer. Are these chemical reactions, physical processes possible? So just now we have given some reaction here, H2O, C plus H2O. This we have to think in this line that are these chemical reactions, physical processes are possible? How much energy is required? How much quantity is required to generate? If it is more than this, no use. To what extent does the chemical reaction, physical change proceed? How much percentage we are getting? How much pollution we are getting? If it is generating more carbon monoxide, then it is polluting the environment, then it will not be succeed. The sustainability of this system will be in problem. To what extent environment gets affected? Any product which we make or any technology we should develop, we should make sure that it should be environmental friendly. It should be eco-friendly. Then only people will accept. Because the age is there that no country will accept any product if it is producing more amount of pollution. Is there any scope of improving the performance of a system or the process? Whether the method which we are following, it is improving the existing product or the process, or it is somewhat better than the existing one, then only it will be accepted. To answer these questions, we need to have a thorough knowledge of thermodynamics. So, to answer these 5 questions, we should understand the thermodynamics better way. Then only we can go for designing of any product. Then only it will be useful. So, we have to answer these questions. So, about the thermodynamics. Thermodynamics is a science dealing with energy and its transformation. So, what is the thermodynamics? Energy and how it can be transferred to the work. So, that is your first law of thermodynamics. Then, second law is equilibrium processes. In this, we have the second law and the 0th law of thermodynamics. This is the equilibrium process. Then we have the entropy. This entropy is in fact not only in the thermodynamics, but it can be used in any of the system. Entropy means it is a loss, like a friction. Everywhere if you go, there will be a friction. So there will be some losses. Those losses we have to understand and try to avoid those losses. So this entropy is also called the third law. All these 4 laws are based on the experimental observation, which cannot be proved directly. So it is not by the mathematics you cannot prove. This mathematical approval is not there. They are by the experiment they have find out, especially like Joules and all, and they have derived these laws. Thermodynamic is a fascinating subject used in almost all engineering branches. So it is not only mechanical, aeronautical or chemical. It is everywhere. Without thermodynamics, even your astronomy, your oceanography, atmospheric engineering, everywhere your thermodynamics is used. Nowadays in computer also, how much heat generating, wherever heat is there, you have to use the thermodynamics. So, in the thermodynamics, we have 3 main elements. First one here is the energy. Then we have the entropy. Third one, and this is the second one, is the equilibrium. So, this component 1, 2 and 3, that is energy, then it should be equilibrium and then entropy. These 3 elements make a system as a thermodynamic system. Like your human body also, we have the whole body here. This whole body mind also should work with your body, and there is a spirit which mind and body has to make. Then a good human life can be made. So here also, if you see, this is the first, this is the second, and this is here. Here also we have the 3 elements. So like human body, mind and the spirit, when you club it, a good human life will come. Same way for thermodynamics, energy, entropy and the equilibrium. These 3 conditions, when you make it, it becomes the thermodynamic. Now, I will try to explain about the application of thermodynamics. Even in this classroom, if you see, we have the light here, we have the camera in front of me, I have the PC in front of me, digital slide in front of me. Everywhere there is a heat, there is a temperature, there is a energy, there is a equilibrium, there is entropy. So this all, wherever we are here, everywhere you will get some application, and these applications I am going to discuss in short. In this room, we have the light, camera, AC, and can be summarized as the thermodynamic application. All engineering activity involves an interaction between energy and the matter. Here are the few examples. So any engineering activity, if you see, there will be energy and there will be some matter. When both they are interacting, there will be a thermodynamic application. In our house, we can see that we have the refrigerator, air conditioning, humidifier, cooking stove, iron, TV, mobile, pressure cooker, and so many other things, bulbs. All things are the application for the thermodynamics. If you see the industrial application, we have the power plant, automobiles, rockets, jet engine, cryogenic system, alternative energy like wind energy, solar energy, biomass energy, nuclear energy, and so on. Biomedical application, cooling and the heating of the systems. Here I have shown some example of thermodynamics. First, our body itself is a thermodynamic body. If you see our body temperature is slightly higher than the atmospheric temperature. If you see your breathing, your heat of the breath is much higher than the atmospheric condition. There is a refrigerator. The second is the refrigerator here. This is a refrigerator. Then we have here the solar cell. Then we have here one power plant or air conditioner. This is the air. Here we have the GT engine, gas turbine engine for aircraft, and this is the power plant of thermal power plant, which normally, or the hydraulic power plant we have here. I think this is the hydraulic power plant, and from here we generate the electricity. So we are converting one energy to another, and here are some examples which I have given. There are some more examples. Here we have the rocket launchers, missiles and all. Here we have the this hydrogen cells and the power plant. And here we have the nuclear power plant. So these are the few examples which I have shown, but everywhere, if you see tree, vehicle, animals, lake, sea, wind, everywhere thermodynamics you can apply. Medicines, your blood circulation, everywhere this concept can be used. Now, scope of the thermodynamics. There are number of scopes like equilibrium thermodynamics, non-equilibrium thermodynamics. So this equilibrium we will be studying this case, not this we will not be studying. Chemical thermodynamics we will not be going, atmospheric we will not be going. Most of the things we are only concerned with the main here. So this equilibrium thermodynamics, it makes the case very simple. Chemical thermodynamics related to the chemistry people, how the reactions are taking place. Atmospheric thermodynamics, you see the cyclone, thunder, storms, rain, other things are happening, and this also we can do analysis, calculate the things with the help of the thermodynamics. Geological thermodynamics, like your earth movement, your other things, motion of your layers of the earth, your other activities. Industrial ecology, pollution by the industry, we can also simulate, we can also calculate, we can also understand. Thermal and statistical physics, quantum thermodynamics, statistical thermodynamics, black hole thermodynamics, biological thermodynamics, psychometrics and the thermoeconomics. Nowadays, a new topic is come as a thermoeconomics. How this economics can be used to understand by the help of the thermodynamics. These are the very, very important areas where we can use the thermodynamics. Here I am at the last, that Albert Einstein's comments on the thermodynamics. So here the great scientist Albert Einstein commented on the thermodynamics as: a theory is impressive, the greater the simplicity of its premises is, the more different kinds of things is related, and the more extended is its area of applicability. Therefore, the deep impression thermodynamics made upon me. It is the only physical theory of the universal content which I am convinced that within the framework of the applicability of basic concepts, it will never be overthrown. Means this concept of thermodynamics is universally accepted, and it will be forever till the nature is there. These laws will be applicable. This is given by the Albert Einstein, one of the greatest scientists of this universe. He has given these thoughts about the thermodynamics. Now, these are the conclusions. Let us learn about the thermodynamics. So, by this concept, we can understand that aerodynamics is thermodynamics is very, very important. So, we all have to learn very nicely. We should take care of that. A matured engineering science topic that deals with all terms of energy, whose manifestation propels the society, an essential curriculum of engineering, needs a proper and profound understanding. If you see, just I am talking to you, it doesn't mean that I am not spending my energy. I am talking, lot of energy is used, and this energy may be useful for the person who is listening this lecture. So this energy is transformed from me to you, which you are observing. So here, if you see, in the next topic, we will be going to discuss about introduction to thermodynamics, branches of the thermodynamics, equilibrium systems and the types, approaches of thermodynamic analysis. These are my references which I have taken from these books, and also the NPTEL lecture from IIT Kanpur, Professor D.P. Mishra. Any questions, you are welcome to ask. Thank you very much for joining, and let's see that we will learn in our next class these all things. Thank you very much. Please do like and subscribe this channel.
Like, share and subscribe. Hit the bell icon for more updates.